Good morning. I'm Devisena. In this lecture, we are going to discuss about PN junction diode and its characteristics. This topic is present in the subject electronic devices and circuits. Let us start discussing about semiconductor diodes. Start with the topic semiconductors. A semiconductor is a substance which has resistivity in between conductors and insulators. Examples of semiconductors include germanium, silicon, selenium, etc. In semiconductors, bonds are formed by sharing of covalent electrons. Such bonds are called covalent bonds. N-type semiconductors. When a small amount of pentavalent impurity is added to a pure semiconductor, it is known as N-type semiconductor. The addition of pentavalent impurity provides a large number of free electrons in the semiconductor crystal. Typical examples of pentavalent impurities are arsenic and antimony. Charge carriers in N-type semiconductors. N-type material has a large number of free electrons and a small number of holes. The free electrons in N-type materials are referred to as majority carriers. Since the majority of current in N-type material is by flow of free electrons and the holes in N-type materials are referred to as minority carriers. P-type semiconductors. When a small amount of trivalent impurity is added to a pure semiconductor, it is known as P-type semiconductor. The addition of trivalent impurity provides a large number of holes in the semiconductor. Typical examples of trivalent impurities are gallium, indium. Charge carriers in P-type semiconductors. P-type material has a large number of free holes and a small number of electrons. The free holes in P-type materials are referred to as majority carriers. Since the majority of current in P-type material is by flow of free holes and the electrons in P-type materials are referred to as minority carriers. So far we have discussed about P-type semiconductor and N-type semiconductor. Let us discuss about PN junction. When a P-type semiconductor is suitably joined to N-type semiconductor, the contact surface is called PN junction. Most semiconductor devices contain one or more PN junctions. Formation of PN junction. Semiconductors of N-type and P-type are brought together. Electrons and holes migrate across the junction. The depletion layer is formed. A potential difference is set up across the depletion layer. Here is the animation. Depletion region or depletion layer formation. At the instant of PN junction formation, the free electrons near the junction in the N region begin to diffuse across the junction into the P region where they combine near the junction. The result is that N region loses free electrons as they diffuse into the junction. This creates a layer of positive charges near the junction. As the electrons moves across the junction, the P region loses holes as the electrons and holes combine. The result is that there is a layer of negative charges near the junction. These two layers of positive and negative charges form the depletion region or depletion layer. The term depletion is due to the fact that near the junction the region is depleted, that is emptied of charge carriers, that is free electrons and holes, due to the diffusion across the junction. So far we have discussed about PN junction. Let us start discussing about semiconductor diode. PN junction conducts current easily when forward biased, and practically no current flows when reverse biased. A PN junction is known as a semiconductor diode or crystal diode. Symbol of PN junction diode. A crystal diode has two terminals. They are anode or the positive terminal and cathode or negative terminal. Here is a representation of a symbol of PN junction diode. Let's see the representation of PN junction diode. A PN junction diode has a white ring. The terminal that is nearer to the white ring is represented as a cathode and the other terminal is represented as anode. This is indicated in this diagram. Biasing and its types. The term bias refers to the use of DC voltage to establish certain operating conditions for an electronic device. In relation to a PN junction, there are two bias conditions. They are forward biasing and reverse biasing. Let us see a small animation of the PN junction diode characteristics. Here is a representation. We are having P-type as well as the N-type semiconductor that are connected to a battery. In this diagram, we are going to discuss about forward bias as well as the reverse bias. Now, forward bias is represented here. In this forward bias, the depletion region is decreased. Now, reverse bias is represented. In the reverse bias, the depletion region is extended. It is indicated here. Forward biasing. When external DC voltage applied to the junction is in such a direction that it cancels the potential barriers, thus permitting current flow, is called forward biasing. Reverse biasing. When external DC voltage applied to the junction is in such a direction that potential barrier is increased is called reverse biasing. So far we have discussed about the forward biasing and the reverse biasing of a PN junction diode. Let us start to discuss about volt ampere characteristic of PN junction diode. Volt ampere or VI characteristic of a PN junction is the curve between the voltage across the junction and the circuit current. Usually, voltage is taken in x-axis and current is taken along the y-axis. VA characteristic of PN junction diode is represented here. Here is a representation. In the x-axis, we have voltage. Its unit is volt. In the y-axis, we have current. Its unit is amps. In this diagram, we have both the forward region as well as the reverse region characteristics. Let us discuss in detail about these forward bias characteristics and the reverse bias characteristics now. Here is a representation of forward biasing of PN junction diode. The anode terminal or the positive terminal of the p-n junction diode is connected to the positive terminal of the battery. Similarly, the cathode terminal or the negative terminal of the diode is connected to the negative terminal of the battery. Due to this forward bias condition, the width of the depletion region is decreased. That is discussed now. P-N junction diode under forward bias condition VA characteristics is discussed. With forward bias to the P-N junction, that is P-type is connected to the positive terminal and N-type is connected to the negative terminal, the potential barrier is reduced. At some forward voltage, that is 0.3 volts for germanium and 0.7 volt for silicon, to the potential barrier is altogether eliminated and current starts flowing in the circuit. From now onwards, the current increases with the increase in forward voltage. Here is a representation of the forward bias characteristics of a p-n junction diode. The cut-in voltage or new voltage for the germanium is 0.3 volts and for the silicon its value is 0.7 volt. It is indicated in this diagram. From the forward characteristic, it is seen that at first the current increases very slowly and the curve is non-linear in nature. It is because the external applied voltage is used up in overcoming the potential barrier. However, once the external voltage exceeds the potential barrier voltage, the p-n junction behaves like an ordinary conductor. Therefore, current rises very sharply with increase in external voltage. The curve is almost linear. VA characteristics forward bias representation is shown here with the help of a small animation. Reverse biasing of p-n junction diode is represented here. In this reverse biased characteristic, the anode or p-type portion of the semiconductor diode is connected to the negative terminal of the battery. Similarly, the cathode or N-type portion of the semiconductor diode is connected to the positive terminal of the battery. Because of this connection, the width of the depletion layer or the depletion region increases. That we will discuss now. With the reverse bias to the p-n junction, that is p-type connected to the negative terminal of the battery and n-type connected to the positive terminal of the battery, potential barrier at the junction is increased. Therefore, junction resistance becomes very high and practically no current flows through the circuit. VA characteristics under reverse bias condition is indicated here. There is a representation. In the y-axis we are having the current and in the x-axis we are having the voltage. Up to the breakdown voltage, there is a very small flow of current that is indicated here. As soon as the breakdown occurs, the current flow takes place in the circuit. This is indicated here. However, in practice, a very small current of the order of microamps flows in the circuit with the reverse bias as shown in the reverse characteristic. This is called reverse saturation current. Reverse saturation current is due to minority carriers. If the reverse voltage is increased continuously, The kinetic energy of electrons may become high enough to knock out electrons from the semiconductor atoms. At this stage, breakdown of junction occurs. It is characterized by a sudden rise of reverse current and a sudden fall of resistance of barrier region. VI characteristics reverse bias representation is here. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means kindly share this video to your friends. Thank you.